Continuing on with solving quadratics, we're going to use the quadratic formula this time along with the discriminant. And I know in Algebra 1 you would have learned the quadratic formula first and then the discriminant. I kind of want you to do it secondly. The discriminant is this number. It's the b squared minus 4ac. It is a tool that you can use to find out what your final answer should look like. And if you look closely in the quadratic formula, this b squared minus 4ac is just the expression or the number that's going to be underneath the square root. So if that b squared minus 4ac is positive, you take the square root of positive, you get a plus or minus of that positive, you get two real solutions. If it works out to be 0, the square root of 0 is 0. You'll end up with one real solution. But now this time, if the b squared minus 4ac is negative, you wouldn't say there's no solutions. Instead, now you're going to have two imaginary solutions, or two answers with I in them. So do the discriminant, know what your answers look like, and then go ahead and use the quadratic formula to find the solutions. So this will tell you the number of solutions. This will find the solutions. And I guess I really don't have it on there, but how you find out your a, b, and c? Well, you got your general quadratic of ax squared plus bx plus c equals 0, where a can't be 0. So in other words, a is the number in front of x squared, b is the number in front of x, c is your constant that doesn't have a variable, but make sure it's equal to 0 before you go ahead and identify those three. Okay, the discriminant also tells you the number of roots. So here I'm looking at a graph that crosses the x-axis twice, so it's going to have two roots, two real roots, and the discriminant would be a positive value. Okay, now this could be opening up or down. It's all about where it crosses the x-axis, because again, roots equals x-intercepts, which equals the solutions. Here it just crosses once, so it's one root, one real root, and the discriminant would be exactly 0. Now, since it doesn't cross the x-axis at all, there's 0 x-intercepts, but there are still two roots. It's just that there's going to be two imaginary. And your discriminant is going to look like a negative number this time. So you got a positive number, you get 0, you get negative. Those are your three options. Okay, so here we go. Remember I said you have to make sure that's equal to 0. So ax squared plus bx plus c equals 0. So I'll have to take away 1. And there's a 1 in front of x squared, so there's your a. B is 3, c is negative 1. And let's do the b squared minus 4ac. So all it's doing is asking me to find the discriminant. So 3 squared minus 4, a little bit of algebra here, negative 1, that's 9. So a negative 4 times a positive 1 times a negative 1 is a positive 4, so I get 13. Since that's bigger than 0, we will get two real solutions. And if you're talking about the graph, that means that that graph is going to cross the x-axis twice. Okay, so I don't know what the actual graph looks like, but I do know that it's going to cross twice because of those two real solutions. And we'll use that information later when we're graphing these a little bit more too. Okay, now let's take that same quadratic. It is the exact same one. I'll subtract 1. Just hopefully you recognize that it is the same thing. So I already know what the b squared minus 4ac value is. That worked out to be 13. I know that I'm going to get two real answers. It's the quadratic formula, and you might remember the Pop Goes the Weasel song to this. That's going to let you actually get the two possible answers, or not two possible, but the two real answers. So I didn't do this work for nothing. You got that number already. It's going to be the square root of 13. Some say negative b. I say the opposite of b. So if it was a positive 3, it becomes a negative 3. plus or minus the square root of 2 times 1. Or negative 3 plus or minus the square root of 13 over 2. Okay, that's what I would leave it as if I were to, leave that as a exact answer. So the square root of 13, if I did a factor tree for that, I can't get anything to come out of there. But if I'm looking at this in a different way, I'm going to actually get the exact answers over some decimals along with it. I can keep on going a little bit farther. So I'll take the square root of 13, which, a little mental math, I guess, that's below 16, so it's going to be smaller than 4. Most of the time, I would say be able to do both. I'm going to ask for the exact answer, but that's about 3.605, so I'll go 3.61. So one of them is negative 3 plus that decimal divided by 2. The other one is going to be negative 3 minus that decimal divided by 2. Make sure you do the numerator first. And one answer is about 0.30. Okay. And then the other one is I get about x is approximately negative 3.31. So you see the squiggly marks, that means approximate. Here would be the exact answers. These would be the approximate answers, or the about ones, because they were rounded. Know how to do both, okay? So here we go. Do the same thing again. We'll do the quadratic formula. We're actually trying to find the solutions, but I'm still going to do the discriminant first. Guess I could bring everything over that way. Or, to save myself the time, I could do a minus x squared. So a is negative 1, b is 2, c is negative 5. So 2 squared so 4, but this time I'm going to get minus 20, so it's a negative 16. So that means 2 imaginary answers, because I'll put the opposite of b, which is 2, plus or minus the square root of negative 16 over 2 times negative 1. Okay, now here I'm going to have the factor tree for 16, which is 4, and because of that negative, that's where I'm going to get my imaginary, my I. So the square root of 16 is 4, and the square root of that negative value is I, so 4i, plus or minus negative 4 and negative 2. Now, what I'll do is, because here, here, and here are all divisible by 2, I'm going to take a negative 2 plus 4i divided by negative 2, negative 2 minus 4i over negative 2. The negative 2 divided by negative 2 is 1. The 4 divided by the negative 2 is negative 2i. So there's one exact answer. And over here I'm going to get 1, but this time I'm going to get a plus 2i. Now if you want to put them in together as 1 plus or minus 2i, that's fine too, but that's how, since I got a negative discriminant, I'm going to end up with 2 imaginary answers. Okay. Try this one again. Not going to talk through this one as much. You guys can go through it, or I'll work through it, but I'm not just going to say all the numbers that I multiplied by, but I'm going to figure out this first. The discriminant always first. Again, the importance is I can help decide what my answer should look like. Why not? So it's 0, and we get 1 real answer. Okay, so again, I want the answers to this, so I use the quadratic formula. So the opposite of b. This is why I get, sorry about that little spike there. This is why I get 1 answer, because the square root of 0 is 0. So if I take negative 2 plus 0 and divide by negative 2, I'll get 1. If I take negative 2 minus 0 divided by negative 2, I'll still get 1. So one real answer. It's the same thing over and over. So there's the quadratic formula. Here we go. I think that one's kind of out of place there, but again, you can go through it. Again, finding the discriminant, describing what the answers look like. You could subtract from both sides, or you could bring the minus x squared over, but I want to say it's pretty much solving that one right there. I think I just got my slides out of order. Okay, so don't worry so much about that, but if you want to describe that, again, you go right ahead. Okay, so here we go. We've got two models here, one where it's dropped and one where it is kind of thrown. Here, the top model is dropped, the next one it's launched or thrown. These variables are described here. H is the height. It's kind of the height at any given time. T is the time in seconds. H with the little zero is the initial height. V with the little zero is the initial velocity, or feet per second in your labels. Science, you did this, but with meters and seconds and stuff like that, but we're going to use feet. Remember that if you launch an object, a positive means an upward launch, so positive velocity. Negative velocity means there's a downward launch. And if there's zero velocity, that means it's a horizontal launch. So no help up or down. Okay, so a basketball player has a teammate who catches 11 feet above the court, just above the rim, and slam dunks it through the hoop. It's called an alley-oop. The first player releases the ball from 5 feet off the ground. For all you guys who love to draw on these iPads, here is your chance. So the first player, all right, has the basketball. That basketball is currently in my drawing, is not the scale, obviously, 5 feet above the ground. Tosses it up there with a velocity of 21 feet per second. Okay, this other person is going to jump up and catch the basketball at the hoop 11 feet tall. How long does it take for him to catch the ball, assuming that the ball is going to keep on rising? So here we go. It is thrown, so h equals negative 16 t squared plus v naught times t plus h naught. So the initial height, 5 feet. The ball started 5 feet. T is what we're trying to find. The velocity would be 21 feet per second, and it's plus because it's going up. T squared negative 16. Now, the final height right there, where the ball ends up, is 11 feet because he's taking the ball from here, from the 5, and he's going up to the ending height of 11. So that's why there's h0, that's beginning. This is your final height. So what we'll do is subtract 11 and get this thing equal to 0. Now, I know it's t squared instead of x squared, but that's okay. That just means that the the quadratic formula is just going to be t equals negative b plus or minus the square root, blah, blah, blah. So here's your a, here's your b, here's your c. Let's just make sure that it's actually possible. Now, I'm guessing it probably is just by some intuition. But, okay. 21 squared minus 4 times negative 16 times negative 6. Okay. There we go. 57. It's positive. There's going to be two real solutions. So t this time instead of x equals the opposite of b plus or minus the square root of 57 over 2 times negative 16. So negative 21 plus the square root of 57, and yeah, I'll use the decimal of 57, gets me negative 13.45. Divide by, this becomes negative 32. So t gives me negative 13.4 over negative 32. Okay, so about half a second, 0.42. Now, if I do this again with negative 21 minus the square root of 57, I get negative 28.5 over negative 32. So divide that by negative 32, and I get 0.89 seconds. Now, if one of my times were negative, I'd say that's the one that doesn't work, but they're both positive, so I got to ask myself which one's the realistic answer. And the realistic answer is this, the 0.89. Because what's going to happen is that ball is going to rise up and hit 11 feet, and then it's going to come back down, kind of like a parabola. So after, here, maybe if I mark this up with a different color, 0.42 seconds, it reaches 11 feet right there. And when it comes back down at 0.89 seconds, it reaches 11 feet again on its kind of downward spin. So there you go. It takes that basketball 0.89 seconds in the air. So that's the applications of the quadratic formula and the discriminant. And if you're a big physical science person, or if you've taken physics before, this is a lot to do with gravity and acceleration. So